Okay, so let's do a couple more examples. Now, the first one is going to have a 7th root. And so when we're doing this, right, when we got rid of a square root, which was a 2, you square both sides. So if we want to get rid of a 7th root, we need to raise both sides to the 7th power. And so you get the right-hand side, which is -1 to the 7th, but -1 times itself 7 times is just going to be negative. So we only have -1 here. The 7th root of the 7th power cancel, so you're left with x squared plus 4x plus 2. Bring everything over to the left by adding 1. And then now again, you're back into a quadratic form, right? So now we can factor it if we can. So here, x is equal to -3, or x is equal to -1. Now, what's really nice about the odd nth roots is you don't need to check whether or not they work or not. So there are no things called extraneous roots, which is what we saw at the other example, the ones that don't work. So once you have this over here, and you find these solutions, those are your solutions when the nth root is odd. Now, the last example that I want to do is going to be one where we have more than one root. Now, it's possible that there's 3 or 4, and what you're really trying to do is follow the same rules. You're going to isolate a root, square or take the nth power on both sides, and then continue that process until you get rid of all the roots. It doesn't matter if there's 2, it doesn't matter if there's 3, however many times you need to do it to get rid of all those square roots, that's how many times you need to do it. So here, in this case, right, we have 2 square roots. So what I'm going to do is I'm going to isolate one of them. So I'm going to get the square root of m minus 2 is equal to 1. And then I'm going to subtract square root of m minus 1 to both sides. So we get minus the square root of m minus 1. Now notice if we just square both sides, the left-hand side, the square root will disappear. So squaring both sides for the isolated radical has the property that they just cancel. Now for the other side, you actually have to do the multiplication. So I'm going to write it out as 1 minus square root of m minus 1 times 1 minus the square root of m minus 1. And then go ahead and do the algebra. The first part is going to give you 1. The second part here is going to give you negative square root of m minus 1. That's also minus square root of m minus 1. And then the last part, they cancel the squares, so you're just left with plus m minus 1. If you want to, again, that's also a perfect square. You can do it like that if you want. So m minus 2, this and this cancel, is equal to negative 2 square root of m minus 1 plus m. Again, isolate the the radical, and so we're going to bring over the m and the 2. So let's subtract m to both sides. So these cancel, and you're left with negative 2 equals negative 2 square root of m minus 1. Get rid of that negative 2 by dividing both sides by negative 2. So the left-hand side is 1. The right-hand side is the square root of m minus 1. So all of this work was to get rid of one of the radicals. But once you get down to here, notice it was like the original problems that we did, where we just square both sides. So squaring both sides, you get 1 is equal to m minus 1, and adding 1 to both sides, m is equal to 2. So again, squares, we have to check our answer. So let's plug that into there. 2 minus 2 plus the square root of 2 minus 1 is 1. That first term is 0. That second term is the square root of 1, and 1 equals 1. So this answer here, that one is okay, and that is our only solution.